Yeah. So good morning, everyone. Today is the August 11th, and let's start today's meeting. And Derek, did you add that the status, like the monitorings at the beginning of the agenda, like what we talk about? Do you want to talk driving that one?
I guess as a highlight, I didn't get a chance to check it this morning. At least for PRs pending approval, I think yesterday when I was looking at this, we were kind of mid-teens, and I was working my way through there. I think for the most part, everyone that was pending a cherry pick has been pulled back, and many of the other ones that were pending approval weren't really necessarily specific to just SIG Node responsibilities. So a number of them actually had a dash poll or others apply their approved. So I think for the most part, the needing approval queue is in decent shape for where we could do our work that was not intersectional with, say, SIG Windows or API machinery. For the other queues, I did not have time earlier this week to pay them too much attention beyond what I looked through the approval queue. So either maybe David or Seth, you had a chance to review?
Yeah, so I actually just had sort of a PSA. I added a third category or a new category from last week as well, which is PRs that need assignees. So a lot of the PRs that don't currently have assignees that are in Node actually have had a number of the people who are on this call already reviewing. So if you are reviewing PRs, feel free, if you'd like to follow through with the review, to assign yourself. That way we know that we don't need to look for someone else. And I've been going through some of those PRs and trying to assign the people who have been working on them.
Yeah, there's also some, like the PR goes to some people, maybe not involved with the SIG Node. So I did pay extra attention on those PR only assigned to some, like the old member. And so the couple of those things, maybe from now on, we have to pay extra attention on those things because we think about they have the assignee, but actually the people not actively on this. So just share with group here, yeah. We might need to fix our bot and to track something. Any other comments on this one? So we are going to keep.
I pasted the statistic on top of a meeting note with diff from last week. How many created PRs, how many closed PRs? Is it useful or it's not needed?
I think it looks really cool. Yeah, thanks.
Yeah. I think it's really useful, and we can maintain over time. Maybe there's some legacy things staying, and but this one actually can help us if those legacy things need already start update. Like I think we'll reflect here, right? So like there's the update one, so then we can pay extra attention about the update one, so people still care. So we can pick up from here over time. Then hopefully we can cover majority of those PRs.
Yeah, one thing that I don't know if anyone from SIG Windows is in today's call, but there's about 5 or so kubelet-oriented changes specific to Windows that it wasn't clear to me actually had consensus in the SIG.
Yes.
And one of the ones that at least I was trying to give some priority attention to review was the one that was stripping unnecessary security context on Windows. Just because I know our own users are hitting that as well. So is anyone from SIG Windows today on the call that maybe could like summarize if there's consensus on the approach for this? Because the PR looked fine. It just wasn't clear that it was an accepted path forward for that SIG. And if not, then maybe given the queue I see here, like we don't have a great way of distinguishing when Windows is happy with something versus Node right now in some of these items.
So Derek, in the past, I did a while back, I did went to the SIG Windows and then ask them to have someone represent the SIG Windows and join SIG Node because it's kind of a joint product, join the project.
Yeah.
Because but Patrick, that's why Patrick joined us, and Patrick left, and so that's why maybe I have to go to the SIG Windows ask them explicitly to find someone represent the SIG Windows and attend this meeting. They could take turn, they could do something, but it is true because they've been poking me, and the problem is I don't have enough content. So for those PRs, we need. There are certain things like the controversial between from the different PR. And so that's why we hopefully in the SIG Node we could, and also I think about it's more transparent in here and to tell us the planning and what's the goal. And so it's hard for us. So that's why maybe we should find someone represent here because the majority of SIG Windows code actually sent to the SIG Node.
Yeah, it just struck me. I was so used to Patrick being here for many months that I didn't actually realize he might have been absent. So I was hoping he was still here. So yeah, if we can find a better ambassador from SIG Windows who's, or not better, Patrick was great, but a present ambassador from the SIG, that would be awesome. And I'm happy to follow up with that myself, Don. So I can try to see what we can do on that one.
Yeah. So last time is I went there, asked them request. So that's why Patrick from his to represent us, just from represent both from Microsoft kernel team to represent of the Windows container, and also from the Kubernetes SIG Windows. So that's kind of cover both. So maybe we have to do the similar things to request explicitly.
Okay, cool. Yeah, because it's hard to, when you look at the pure data, to have a clear split on some of these things. And so anyway, we'll follow up on that.
Sure.
But that's probably the best summary of what I see.
Okay, so let's move to next one. And Virok, do you want to talk about the static container? Yeah. I think you just want to ping for the review, right? So
yeah, sorry, hello.
Go ahead.
Yeah, sorry. Yeah, I wanted to do a friendly ping on the OpenPR. I know like the 1.19 release is coming and KubeCon is coming, so I guess there won't be much activity. But yeah, I wanted to know if on the other side, maybe before KubeCon there was a chance to get a review, or yeah, just to know what to expect.
Yeah, I'll review this afternoon. So thanks for the call out. And I don't see, just because 119 is held up doesn't mean that we can't iterate on the updates to the CAP. So I will follow up on that this afternoon.
Okay, perfect. Thank you very much.
I think the SAS and also the Sergey already reviewed, right? So it's just, I think that we did assign to several people when we talk about that earlier this beginning of this quarter. So there's the SAS and there's the Sergey and there's the Eric, if I remember correctly. And
yeah,
those assigned to this, right?
Yeah. And Sergey left some minor comment, but yeah.
I think my biggest comment is, my biggest comment is about init containers. Like, can we, like, talking to Istio team, it seems that init containers, like running after site containers initialized, is very important for certain scenarios. And my question is basically what will change in the entire CAP if we will just start site containers before init containers?
Yeah, so to sum up, but it's on GitHub if you prefer to move the discussion there. But what I mentioned is basically right now sidecar containers are started after init containers. So init containers can be used to initialize some volumes or something that sidecar containers will be able to use or might need. So if we create a new definition of sidecar containers that are before init containers. Not all possible sidecar containers now are might need another init container for sidecar containers, or semantics can start to get tricky. And so I'm open to that if that it's better for the long run. I think we should do that, but I think that is quite a different problem of the one that we currently know. Like sidecar containers as we know them today start after init containers, and there are a bunch of users doing that, and those are the problems that I think it might be easier to start solving by. But yeah, I want more, of course, more opinions.
So Rodrigo, the one help I could have if you could do this after the call was the KEP right now is under SIG apps, but I don't really see SIG apps as being like a long-term stakeholder here. If you could just move it under the SIG Node directory, that would probably ensure that we don't hit any other approval headaches.
Sure.
But I know SIG apps historically brought the use case forward, but it seems like from a implementation ownership perspective, this is pretty clearly pod and Node.
Yeah, should I add that commit to the same big PR, or maybe a simpler,
just do a commit to move that to an alternate directory? That's fine. It shouldn't get confused.
But I mean, in the current open PR, that might be that might take long to merge, or maybe it's just another small PR with that change.
Ordering is fine. If you want to have a PR to move it into Node and out of apps and then do a separate one, that's fine. Or you can do on this existing one. It just, it seems like it's bucketed in the wrong SIG.
Okay. I agree with Derek. That's kind of since we already have the process based on the label, right, which is SIG, and that's easy for us to book tracking. Since the majority work ask this team to do the review, design review, and the implementation review, all those kind of things. So it maybe just try to reflect the facts here. Otherwise, we may overlook this one. Even we talk about this so many times, but since we do the procedure and now look at the label and the signal and try to do better job about those type and the PR, and so maybe we should enforce those tedious small things to help the process.
Cool. Awesome. I'll move it to SIG Node.
Thank you.
Thank you very much.
Yeah. So let's move to next topic. And Sweaty, and there's the topology file scheduler, and cool. I'm looking forward for the demo.
Yeah. So hi everyone. I'm Swati. I'm here with Alexi and Francesco, and just wanted to provide a quick status update on the topology aware scheduler work. We've been talking a bit about it, so I thought that it'd be good just to provide a status update and show a demo so people know what's going on there. I have a few slides. If you can give me access, I can just share them.
Totally. Give me 1 second. I need to find it. You can go.
Okay. There you go. Yep. Yep. Let me know when you can see the screen.
Yes.
Okay. So, yep. So basically, the status update is that we've been working on these two components, one of them being topology aware scheduler plugin, the other one is resource topology exporter. We have KEPs and implementation of both of these components. As part of the resource topology exporter, we initially prototyped it using the container runtime interface. We've enabled it for Containerd and Cryo. This required no kubelet changes, but when we kind of started looking into pod resource API as a way of gathering resource information, we identified that there were some gaps that needed to be fixed, and we've proposed a KEP and code corresponding to these as well. Alexi, if you want to talk through this one, he basically authored the KEP and implementation of this.
Yes, hello everyone. I have a couple words about it. I think the changes in port resources was raised by the thing that we need to rely on interfaces with CRI. We was not able to reach such a condition. From my point of view, port resources should come first in review, then a daemon, because it depends on it, and then only then topology aware scheduler plugin. So that is my opinion. Swati?
Yeah, so basically, the pod resource API as it stands today, it exposes information about devices. And what this KEP essentially does is it enables and provides you information about the CPUs and the topology information corresponding to the devices. So that's kind of the summary of this KEP. And then I'll be showing a demo. I'll probably hold that for the time being, but talk about these two items which are currently in progress. So Derek pointed out that we should look for ways to merge the resource topology exporter into node feature discovery. So discussions are currently in progress with NFT maintainers. It seems positive at this point in time, and we're having discussions related to how we can go about it, basically the design and basically design discussions. So we have an issue created for this and a proposal doc. And then in relation to the pod resource API, again, we have an item in progress, which Francesco's on the call again. He's working on. We are proposing that we expose a watch endpoint in the pod resource API. We have a KEP for that, and that would enable us to make resource topology exporter more event-based as opposed to the current design where it is polling. So that's the idea. So so basically a lot of items in progress, but all of these kind of help in enabling topology aware scheduler. So
So
if
I had a
anyone
quick question,
has,
if it's okay.
sure.
If I recall, the reason the earlier iteration of the CAP before I know that y'all started looking at node feature discovery was wanting to basically kind of consolidate like the security model for all of these components. Can you refresh my memory if it's okay, or maybe those who haven't tracked it, like, is the pod resource gRPC endpoint exposed per node? And then is there thought on like how that's secured? Like, is there some strategy around like TLS enablement and cert rotation that people would need to think through on this?
So as far as I understand, for the pod resource API endpoint, I understand that it's exposed per node, and the information you can gather it from a specific endpoint. It's a socket file. In relation to the security aspects of it, I think I would need to talk to someone else who's of more expertise in this area. I'd probably need to look into that.
Derek, Derek, we already put that section in document which you can find here, proposal doc. So you can find there a description how it works in details and some security aspects.
Yeah, I'm happy to follow up on that. I was just trying to make sure I knew which doc. So like node feature discovery, to my knowledge, didn't deploy a new serving daemon per node. It just propagated the state of what was discovered on the node back to the API server, but like it didn't have a new serving endpoint. And so what I was trying to just make sure, am I accurate understanding that you all are proposing a new per node serving endpoint, which I'm just thinking through like deployers who print this out. they would have to handle the serving endpoint for the kubelet as well as for this additional daemon.
Yeah, so we have actually a number of ways of doing it. That's what is captured in the proposal doc. One of them being that we propose another source in NFT worker itself, and the other one being a separate endpoint. And in that, we would have to connect to the pod resource API endpoint.
Okay, I'll just do my homework and follow up on it afterwards, but
Sure.
thanks for clarifying.
If there are any other questions, I'm happy to answer. Otherwise, I'll just move towards the demo.
Just a note about what Derek just meant. Hey, this is Vanko. NFT has TLS, but we haven't implemented cert rotation. So this would one thing be what we need to implement for NFT. But there is TLS for the gRPC endpoint, which is already there in NFT.
No, but Svanko, on the serving side for NFT, right? Like my recollection with NFT was that you had a per node daemon that fleeced and then sent that information back up to the API server.
To the NFT master, and then the NFT master is talking to the API.
Yeah, right, and so there was no serving port opened to the NFT daemon per worker, and so there wasn't like any need to do anything other than handle client certs back to the API server, but there wasn't necessarily a serving cert problem.
Okay.
And so all I was asking about was if the proposal here is requiring an additional cert management for serving per node, like, because obviously the kubelet serves an endpoint 10250 or whatever, and managing certs for that serving endpoint is often a challenge in adoption or deployment. And so I was hoping we could get to a spot that didn't require any new serving endpoints per worker because of the overhead of managing those certs.
Okay,
versus
good point.
Client certs are fine, right?
Yeah. So maybe we should think about of reusing the gRPC endpoint we already have in NFT, but I think this is also a discussion with Marcus, who is the lead on NFT. But thanks for pointing this out. Yeah.
Yeah, I guess in general, like whether you're proxying or doing something else, like thinking about adoption of this stuff, it's much easier if we can avoid needing to serve endpoints on public ports per worker node in a cluster. And maybe Dawn, you would agree with that as a general principle, but I'm just kind of on the lookout for things that introduce new ports needing to be exposed per node and what serving certs they might need to then have rotated. And this is also just like a general challenge when we talked about cAdvisor and stuff in the past. Like there's a lot of operational benefit with the fact that kubelet fronted it for a long time, that as we proliferate daemons out, it gets a pain.
Yeah, this Marcus. So yeah, that's a good point, and we'll keep that in mind. So yeah, it's really good point.
Cool. Thanks for that.
One question which I asked in the PR and one of which Kep's proposal, but I didn't get answer, is the changes to the pod resource APIs. We will show only the devices which is allocated to the pod, but it doesn't give the information what resources are available on the node. So how the already allocated information will be helping you with this scheduling decisions?
So at this point in time, kind of we're at the POC stage. We are enabling SROV device plugin, and in that case, we pass back the PCI. We pass a config file which gives information about the devices that have been enabled in the cluster. So that's the current stage. But what you're saying is correct. We need to look into how do we gather information about all the devices that are available in the cluster.
So practically the current implementation is just using the assumptions of one particular plugin one particular device.
Yeah.
Alexander, did your question was about the node capacity, the nodes available resources, right?
Yes. So the pod resource API you will get entry only when the particular device will be allocated to something.
Yes, but we can get allocatable resources just by kubelet. Kubelet exports allocatable resources to the cluster, to the kube API server.
But it exposes it just as a number, so you don't get information about particular device IDs. So kubelet says what I have resource 1, 5 pieces.
Yes, but we also can export it in the export of daemon in the same way as kubelet did it. But yes, of course, we don't know the configuration of device of all device plugins.
So that comes to my question of the changes to the pod resource APIs. So you are not really exposing the actual topology information about the devices, what is announced by device plugins. You only see after the fact allocation if some of device ID already allocated to something.
That's correct. I'm not sure. Maybe C-Advisor could be something that we need to look at to identify available resources. I guess this information is available within kubelet, but the information about available devices itself would have to be exposed somehow. We haven't explored that yet because we decided that we, for the time being, just focus on a single device plugin, get an end-to-end working solution, and then maybe generalize it across various devices.
No, Alexander, right. We need to know exact resource names. That resource names usually comes from, for example, a server device plugin config or another device plugin config. It config depends.
Yep. And that's the current implementation. So we have it based on a config, and we're gathering information of all the devices that are exposed in a cluster. And then based on that, we evaluate what are available and, kind of subtract them from the already allocated one. So the scheduler gets information about what is available now on a NUMA node basis.
I had to interrupt it here. And for tracking of the time, we have the several things proposed. And are you going to give a demo here, or we can, because I saw you already have the link there, or you want people to watch the demo behind offline?
Yeah, it's a very quick demo. It'll take me about 2 or 3 minutes, so I can quickly go through that.
Yes, the resource API, that's a lot of topic. And we can come back this next time and dedicate one meeting for this. Thanks.
Sure. So before we kind of dive into the demo video itself, I just want to give an overview of the environment that this demo showcases. So we have 2 worker nodes in the cluster. Each node has 80 CPUs and 10 SRV devices configured, and they're again distributed across 2 NUMA nodes. So as you see in this, we have 40 CPUs on each NUMA node and 5 devices on each NUMA node. So from Kube Scheduler's point of view, it sees that there are 10 devices, SRV devices on both the nodes, and 80 CPUs on both the nodes. But then topology-aware scheduler's view is more granular. It has view of various NUMA nodes and how those resources are available on a NUMA node basis. So, so when I demonstrate the demo, there'll be certain workloads already running in the cluster. So these are the workloads that are running. So I have a pod which is requesting 5 instances of SRV device, 5 CPUs. That is over here. And then I have a workload that is requesting 2 CPUs, 2 SRV devices, and 3 CPUs, 3 SRV devices that you can see over here. So from scheduler's point of view, like Kube scheduler's point of view, both the nodes appear to be exactly the same because we have 5 SRV devices available on both the nodes and 75 CPUs. But when we look at the NUMA node side of things, the picture is completely different. So if a request comes for a pod, which is something like this, so we're requesting for 4 SRV devices, this information becomes really valuable in that case because Kube Scheduler could place it on either of the nodes. But in a cluster where single NUMA node policy for topology manager is enabled, if the scheduler places it on this node, the pod would end up in a topology affinity error. So the topology aware scheduler plugin uses the information that we have gathered and which is more granular to place it on this node, and then in turn it gets placed on the first NUMA node. So basically we'd have something like this. So that's what I'm going to be demonstrating in the demo. Maybe let's go to the demo. Okay, so I have here showing that I have 2 worker nodes. There are 3 virtual masters as well on this cluster. SRV network operator has been deployed on this cluster that will basically show information about the statement will show information about the allocatable. So as you see here, we have 10 instances of SRV node on the first worker node, and the second worker node has 10 SRV instances again. And now I will be showing, let me just go back here a bit. I'll be showing here the 3 workloads already running in the cluster, which you can see on the left as well. And then I'm showcasing here, I'm showcasing here the NUMA nodes that they're allocated on. So for simplicity, what I did in this cluster was the PCI addresses that are ending in an even number are all on NUMA node 0. So here you can see that these devices, PCI addresses, or the devices that have been allocated to this pod are on the 0th NUMA node, as you can see over here. And then for the sample pod 2, you'd see this is again on NUMA node 0, which is over here. And then this is the sample pod 3, which is on NUMA node 1. So now I'll show the CRDs. In this case, we have node resource topology CRD in this cluster. When we kind of show the instances, you see that there are no instances corresponding to the CRD. And then when we deploy the resource topology exporter, those CRDs are populated. So here we are deploying the resource topology exporter. So we have, because it's a daemon set, we have an instance for both the nodes, and then we have the CRD instances populated corresponding to both the nodes now. So this command is going to show you the picture of basically the information corresponding to the specific node. So here you can see there are 35 CPUs available on this node and 0 SRV devices, which corresponds to this information over here. And then for the other node, for the NUMA node over here, you see that there are 40 CPUs and 5 SRV devices available on the NUMA node 1. Now I'll show you again the same information corresponding to the other worker node, and it will again match what you see in the diagram here. So we have CPUs, we have 38 CPUs on this worker node on NUMA node 0, and then 38 CPUs over here, and 2 SRV devices available over here. So now we deploy the topology aware scheduler. We deploy it as a separate scheduler itself. We deploy it in the kube system namespace. So that's the command that deploys the scheduler. Now we'll just quickly check if the scheduler is up and running. So we have it up and running. Now we deploy a pod requesting resources using this scheduler. So because this is deployed as another scheduler in the cluster, in the pod spec, you would see that I'm specifically mentioning which scheduler is deploying this particular pod. So this is the manifest file, and you see here that I have the scheduler name specified as my scheduler to indicate that we need to use another scheduler in this case. Like ideally, once we have the topology aware scheduler plugin merged into the mainstream scheduler code, we wouldn't need to do this, but this is how I've done it for the demonstration purpose. And now,
can you elaborate on that? Why is that not needed? Or you're saying that once it was merged, you would have it, you'd always be topology aware?
like, yeah, depending on like if you have a single UMA node policy specified on the certain nodes, then that's only when the topology aware scheduler plugin would kick in and it would try to schedule pods based on that.
Okay, so the expectation would be that both the scheduler plugin and then the resource that's coming from NFD that gives the, or potentially coming from NFD that gives the associated topology policy on that node, they'd work in concert just out of tree.
Yeah, and we would like to make it more kind of configurable as well. So if someone doesn't want this plugin to be enabled, they could just simply disable the plugin. So my understanding is that the scheduler config itself allows you to enable and disable plugins on your cluster.
Yeah, this would be helpful because we are working with some customers and labs that want to engage or enable other schedulers on OpenShift, but they are depending on the exact information what we need from NFD or other entity which exposes the NUMA topology. So it would be really mandatory to disable this scheduler so that other schedulers can onboard and use the same CRD, CRs, and information that we are exposing either via FD, NFD, or other entities. But I have several customers who want to enable from the HPC space schedulers that need those information.
I agree with you because the different use cases. This one definitely give us the boost for some performance sensitive or maybe some device sensitive of the workload. But also there's something like that you have to treat off for some like the if that workload is not that performance sensitive, like some like the product batch workload, or even like the some is like the latency sensitive, but actually it's not that depend on the memory intensive workload. So in that cases, this actually will hurt of the utilization. So this is why we want this is being the extensible and out of the default tree. And so then basically it's more like the from like the cluster level, per class level, or maybe like a per node pool level, you could enable those kind of the scheduling behavior. This is, I think, this is kind of what we try to push so far. So.
Okay. So just to wrap up on this, so we have the scheduler deployed when we have a specific pod being placed by that scheduler. So we just create that pod, and here you can see that this pod gets created on the 0th worker, which is this one, as expected. So that kind of finishes up the demo.
Thanks. We ran out of the time. Otherwise, I will ask the other people have more question raised, so we can follow up offline on this one. This is
Sure.
such a great demo, and thank you for coming and give the status update and of the great demo. And so next, if you have more questions, please talk to the Swati, Alexei, and Zhang. And let's move to next topic. Is that okay? Thanks.
That's perfect. Thanks.
Next one, Seth, do you want to open the discussing on that Yeah, I think that we talked about briefly touch base this topic last week.
I'm not sure if we talked about it last week. I think it was a different issue last week, but this one was interesting, and I wanted to get some feedback. So when we do enforce node allocatable today, that puts a memory limit on the kubepods C group, and sets the shares. And this is where it gets tricky. Like, so shares is a ratio, right? It's a relative number, but we deal it with CPUs in terms of millicores. So we have this, we keep them on the same scale so that they continue to make sense. But when you set like the system reservation to be, like we have customers that'll set like a 4 or 6 core reservation on a 96 core machine, right? Really big. And so what will happen is because you're not doing enforcement on the system reserved, so you can do pods, system reserved, cube reserved, right? If you don't do the system reserved in the enforced node allocatable, then the shares is not set on the system C group. And so even though you reserved 4, 8, 10 cores, under contention, the system slice, or I'm speaking in system D terms here, but the system C group does not effectively have access to the reserved CPU count because its shares isn't set. And that throws off the calculation system wide, where KubePod slice has allocatable number of CPUs and the system slice always has 1024 because we don't set it. But if you add those two numbers together, it doesn't add up to the total number of millicores on the system.
So what is the recommendation, Seth? That, I mean, today, if you had said enforce system reserved, so like default, we say enforce node allocatable would be pods. And so we write what's on the QPod C group, but then you're right that nothing gets reflected on system slice. For CPU, that's always wrong. So like, I think the tension I feel like Vish and I had when we first did this was we didn't want to cap memory because memory was always going to be probably wrong. And we wanted to let some burst on the system. But reflecting on this now, like especially with larger boxes, like where you're not running 4 vCPUs, but you're running, in your case, you said 96, the imbalance on that ratio can get really extreme.
Yeah, and it's actually even more out of balance on small machines. So like if I did a 4 CPU system reservation on an 8 core box, well, if you add up shares and convert that to millicores, there's only 5 cores on the box, right? Because system slice has 1024, QPod slice has 496. And now you've like, now 3 CPUs are unaccounted for in the shares.
So is the proposal though to saying no matter what you set enforce node allocatable to, we always want to set CPU shares to a value?
Well, we can't really do that because this is where the tricky part comes in. So if you set system reserved as a key on enforce node allocatable, that makes it to where the user has to provide the system C group name as a parameter to the kubelet. In system D's case, that would be system slice. But it makes that required at that point. But if we don't require that, then we don't technically know what the system C group system C group name is, even though we can assume it in a lot of situations based on the C group driver. So I'm not sure if we can just blindly start setting CPU shares on the system C group slice without messing up backward compatibility.
Do we require cube reserved to be within system reserved? I thought they were accounted for separately against node allocatable.
That's the initial design. It's separable. Yeah, it's system reserved initially. Since I came from this, initially is for the any daemon not Kubernetes managed, include of the kernel. And then the cube reserved actually is for all those daemons. and like Kubernetes container runtime and other some like the kube proxy back then. That's for the kube, just like the Kubernetes provide the daemon or daemon side or whatever. And that's kind of the original source. Just share here.
The only way I can see out of it is to have people start setting the system reserved key for node allocatable, and then setting CPU shares, but not setting memory limit in bytes when you do that. I think that that is the behavior that most people are expecting. But if the existing behavior is to set memory limit in bytes, and for some reason people want their system daemons killed if they go over that limit, which I don't think is the desirable outcome for anyone, but it could possibly be the current behavior and what people expect. Then I'm not really sure. My understanding is that we do set memory limit on bytes on the system C group if you pass node allocate, if you pass the system reserved key to node allocatable, to enforce node allocatable.
Yeah,
is that
my
right?
memory is the same.
Okay.
And I think that that is, it's probably an error in when we first thought about this to not allow you to distinguish enforcing things that are, I'm having a word, compressible, right? We should have a way of expressing to enforce compressible versus incompressible resources. And we have that globbed together into one concept right now that it's probably a mistake. So the issue you're raising here is basically a report, but there isn't like a proposed fix, right? Or did you have a proposed fix that you wanted to draw attention to?
I don't currently have one because I don't have a solution that is transparent to the end user, right? It's going to change the behavior of something. It's just what behavioral change is going to be the least disruptive and more aligned with what users expect, I guess.
Hey, this is Michael. Just for my own knowledge, why is CPU shares even used at all anymore? Like C groups v2, that stuff's going away, and it creates a very inconsistent latency profile. Like, why isn't CFS quota just used across the board and CPU shares just ignored?
For our burstable quasi tier, so like it shares allows so in the pod spec, when you make a request, that maps to CPU shares. When you set a limit on CPU, that maps to CFS quota. And shares allows a pod to burst beyond what it has requested as long as there is not contention on the machine. But the shares are there to enforce fairness when there is contention.
Yeah,
it'd be the
I get the
equivalent of
burstable.
CPU, right?
Michael, can you finish your sentence? Sorry.
Yeah, I get the burstable part as they can do more. I don't know. I've always been against CPU shares because of that. Like if you look at it from latency profiles, like depending on if you're looking at a workload isolated, depending on how much is run on a single machine, you get really good latencies and stuff, even for burstable tasks. And then the machine gets bin packed. And now like I, as a batch user, my things are taking 5 times longer. And that's the sole reason why CPU shares, like it, I don't know. I think especially with C groups v2, it's going away. Maybe a solution to fix this is to look into if this needs to be used at all anymore. It seems kind of a thing of the past to me as far as resource management goes.
Michael, can you clarify that? Because I view CPU weight as the equivalent to CFS shares in that it's proportionally distributing, and C groups v2 has CPU weight.
Yeah, same.
All right.
So also in V1, there was a very bad kernel bug with AFS quotas, which was only fixed late last year. I can link to some issues, and there are some.
Even right now, fixed still is not fixed. Some corner cases still have some problem. So that's the problem. So we end up to have like the provincial, the special treatment on different of the workload. So by default, we still didn't enable of the CPU quota, the limit.
So
yeah.
I think even on Secrets v2 host, right, and Renaud and Giuseppe, I know you guys are looking at this. We would still want to be able to set CPU weight on system slice or system or cube slice, whatever people have their C group taxonomy set up as, to balance appropriately between end user pods and system services. So like, I guess I don't have like a great answer, Seth. I don't, because I feel like if it were me, I don't think anyone in the world is setting enforce node allocatable in a way that they understand what it's doing. That like, I feel like I would improve the world if I did set shares on it because it would match the expectation probably they have. But I don't think I can do that, and we probably should kind of queue something up in 120 to say we'll fix this by distinguishing between enforcing compressible versus incompressible resources. That's my first thought, because like taken to the extreme, like you might want to restrict the amount of PIDs or tasks that you might proportion out, and like same with memory. And like I personally probably would never run a kubelet worker where I enforced compressible or incompressible resources on the system daemons. But maybe others have a better understanding on the workload that they would. But that's probably the best pitch I would have, that we could probably queue it for 120 and like make the world a lot better. Maybe others feel different.
I almost feel like it's a bug for us to not set shares. In other words, if I set enforce node allocatable pods, then it feels like that's wrong unless we're explicitly setting CPU shares on other C groups that's balanced against.
That's a fair perspective too, actually. I like that.
I agree with that. And really the only hitch with that is that we can't assume what the system C group name is.
Right.
Unless you pass the system reserved key into enforce node allocatable, which forces the user to provide that to us. So the only way I see forward is users will have to set the system reserved key for enforce node allocatable if they want the shares set on their system slice properly, because that forces them to provide us with the.
But could we? I'm sorry, Seth. But couldn't we do like just find all peers of the QPod slice, and set it appropriately? With that, like if you only find one peer, then you know what to set it. If you find more than one, that may be an issue. But I think if you find just one, you could auto know the right balance to do, right? You find all siblings of QPods. If n equals 1, you know to set shares to the alternate value.
I mean, if that's only if there's one other peer to cube pod slice, right? Which for systemd, that's true. System slice is the only peer to cube pod slice.
Unless like user slice appears there or something, depending on how people had worked. Yeah, I don't know if I have a brilliant idea then.
The other thing we can consider is setting all shares.
Interrupted a bit because we also have some other 2 more topic here. Sorry, and we don't have the best answer here. Can we carry that one through because like there's no one size fit all node allocatable config. And the different, if you are thinking about the telecom use cases, and they are really sensitive for every single things, and you are running, allow those new, even a Kubernetes running. So we are carry on that to the separate topic later. And can we move to the next one? Yeah. So Starward, do you want to talk about the topic we've been used to be talked about at the SIG Node, the node readiness gateway, and most focus on your problem, because I think there's no, that's just a proposal, one way to solve your problem.
Yeah, okay. So just to give a brief overview, my proposal is really just that we reopen this Kubernetes enhancement proposal for node readiness gate or node readiness gates, which basically just adds a declarative API for defining a set of pods which all must be ready on the node before the node is considered ready. And I'm coming over from Istio. I work on the CNI or Istio CNI over there, and our use case is kind of odd, but it is, I think, kind of representative of this class of problem. So to give you an overview of what we're doing, Istio CNI is basically a binary which installs a which is installed on the node, and is called just like a normal CNI binary is. It's installed by a daemon set, which runs the installer and then adds the binary and also updates the configuration. However, unlike most CNI plugins, it doesn't cover the entire kind of networking stack. The only thing it does is actually exec into the pod namespace for a given pod, the network namespace, and execute some IP tables rules to set up port capture. So the issue here is that since it's not a true CNI, there's nothing that actually stops a pod that is scheduled before that CNI or plugin is installed and chained to whatever your main CNI plugin is from being scheduled and starting up successfully without those IP tables rules being applied, which means that if you have a workload that depends on running Istio, you will run into a problem where you have this pod created, but it can't actually execute. So it's basically just sitting there dead in the water and consuming resources on your computer. So we call this the CNI race condition over in Istio, and the problem here is that because of the way that this is implemented, we cannot actually repair these broken pods in place. Because CNI is only called during initialization of a pod network namespace. So while we do have mitigation measures, basically a init container which detects when the pod is broken by just running a couple of loopback commands to see whether or not the IP tables are in place. If it's broken, the only thing we can do is delete the pod and let it reschedule itself. And that is, it creates a lot of noise on the cluster. You might see if a bunch of pods get scheduled because the cluster is in high contention, you may see pods get rescheduled, 50 times each. And for a large number of pods on a cluster, that creates a lot of noise in your metrics and makes it look like something horrible is happening. When normally it's actually just trying to repair itself until the CNI is installed. So CNI is a requirement for a lot of customers, or Istio CNI is a requirement for a lot of customers because it allows people to actually run Istio without having to break their pod security policies and give the workload pods capnet admin, which is required in order to run IP tables inside of a pod network namespace from a workload pod. So the proposal was initially closed with the comment that a taint controller with register with taints would be an acceptable workaround. And while it does work, it still kind of isn't a great solution. The problem here is that the node itself, or kubelet, has all of the information it needs to make the determination of whether or not it's ready. So if we had a declarative API where we could state the conditions in which that's true, and let kubelet manage it, it has the ability to stop things from scheduling on it without any kind of lag. Whereas if you have a problem, or the problem with running it as a taint controller, which is running outside of kubelet, is that if a node comes up, reports itself as ready, and there are a large number of pods that are sitting there waiting to be scheduled, they can all be scheduled onto the node before that taint gets applied. And if that happens, you'll have a large number of these pods which are sitting there and in an unusable state, consuming resources. And if you don't have the repair controller enabled because it makes too much noise in the cluster or whatever, they'll just sit there and be completely useless, which breaks your monitoring, which breaks autoscalers, and they won't ever be descheduled because there's no mechanism for you to actually go clean them up without something that just deletes the pods. The other aspect of that, the recommendation was for this taint controller to also be coupled with a repair or register with taints option in the kubelet. And the problem with doing that is that that's not always available. And even when it is available, a lot of times the team that is managing Istio at a large company does not actually have control over the arguments that are passed to kubelet. So if you have complete control over the system and it's one that allows you, to actually set the register with taints option, yeah, you do have a workaround there. But again, it requires you coordinating with two components, one inside of the cluster, one in kind of meta configuration space. And it's just kind of not as clean as just having a declarative API where we can state, this is the set of, label selectors and namespaces and node selectors, where a node with this node selector is not valid unless it has a pod, matching this label inside of this namespace running on it. And so that's a basic summary of kind of the Istio CNI use case, which when I'm giving a specific to Istio CNI, but it generalizes, I think, well to this class of problem. And it's something I think that we really do need to have implemented in some form.
I just want to summarize. The general actually is just we've been talking about what after under what kind of condition a given node it is ready and take the user workload. We've been have those discussed in the past. In the initial Kubernetes founded, we expressly say like the node management is out of the Kubernetes scope. So then that's why initially I put those things in the init script. I think that's address a lot of problem in the past because Kubernetes most built on top of the cloud provider or maybe used by private region, a private on-prem cluster by those each company for their own. And so they could control of the node initial time. So then we have the initial script and then ensure of this node through the cloud provider and the node initial time. And then they can say, oh, this node is attend and get several status is ready. And even we introduce of the daemon side, but the problem it is still daemon side there's also have the risk. So that's why we always go to the init control. So Istio's use cases is a little bit different. So just it should be common, like when I want to join a node and how I'm going to ensure doing that ensure of when I join the node, I have like the clear, like what Stewart say, like the declarative state. How we are going to say this node is ready to serve, because this node is ready could be like this node is boot up and is alive, and then this node is ready. It is okay. Oh, my node have some certain role, and that certain role require of the certain functionality enabled. The functional enable could be the daemon side is running and device plugin is running, for example, and then I can claim I'm ready. So there's also like when we have the cluster SIG cluster lifecycle and start talk about the cluster API. So I talked to engineer working on that one. I said we do have the init container, and then we do init script. We also have like those things like the initialization for the node startup. How we are going to solve that problem in cluster API. I didn't say they solve that problem because I think that's kind of literally when node come up and they maintain off the machine lifecycle. And when machine come up alive and then create of the node object and the register, there should be have some state like they say, oh, I want to initial this node and for its ready state, but I haven't say that yet. So I think this is kind of like the it's kind of like the common issue, but I guess every provider already have that because given history, legacy region already have their own solution. But I still think about maybe it's a good time for us to revisit things since we change of the Kubernetes scope in many ways, like at least we have the cluster API. So that's why.
So one additional thing I would add to that is that one of the problems with relying on the init scripts and things that are actually inside of kind of the meta config plane or meta configuration space of the Kubernetes, like the kubelet arguments and stuff like that, is that if you start relying on that, you're essentially tying your kind of that your deployment of application level resources that may change the requirements for what is needed for a node to be ready for a given node pool, and you're tying that to the configuration of the entire cluster as a whole, right? So you're if you wanted to push a change or something like that, you would essentially have to roll the entire node pool over with the new configuration settings, as opposed to just kind of configuring that inside of a KRM and just applying that KRM just like you would any kind of custom resource. And redefining what it means to be ready, and then rolling your application over, so that it is now reflecting the new state. It just drastically complicates upgrades and deployments of that kind of, that kind of process.
Totally. That was just that's the legacy vision, because due to the scope, Kubernetes, that's why we cannot. Derek, you want to comment?
I guess I don't. I think it's a universal problem. I don't know, or is the pitch here that we're going to bring back this KEP, or because I'd be interested in sharing like challenges we have as well that I don't think are necessarily met by this KEP either. But is there a what's the goal, I guess? Do we want to revisit this problem, or are we going to say that it's like the infrastructure providers challenge to work through?
On my part, my recommendation was just using that as a starting point, and if we need to remap that, to meet additional requirements that come up, we could probably do so. But the issue is that at the moment there's kind of no proposal out there to solve anything in this class of problem. As far as I can tell, this is the only thing that I saw in motion regarding that, and it was closed with the taint controller being kind of the recommended alternative, and that doesn't really meet all the requirements that there are. And so, either reopening this or opening a new one that kind of uses this as kind of a subset of it. I don't have any preference either way. That's up to you guys, but I just wanted to make sure that kind of I had presented a use case which was not met by the recommendation on that that KEP, and so that we could reopen that discussion.
Yeah. So I have to revisit my understanding on what that KEP had been, but my like lived experience with this is that like when a node is considered ready seems to vary based on both the vendor's choice, this node's now ready, and then the customer's desire for what needs to be on that node before they also then run other workloads, that you end up with like a ring type situation where like if your provider of Kubernetes doesn't provide you, say, log forwarding, but your organization demands that log forwarding is deployed to that cluster, and then you use Kubernetes itself to deploy fluentd down to that cluster, like you end up with these security rings or node readiness rings, which I know is kind of what this gate proposal was talking about, but it's hard to get to like one true solution. But I definitely can empathize that it's a problem. I'd have to go back and think through like variations that people had done with tainting. The problem with taints is that then you need to have those system services tolerate all taints, which also then becomes a problem. So I can definitely agree that there is a challenge here. It's hard to come up with one true answer, because one user might say, oh, sysdig or fluentd or insert random thing must be on this node before my workloads are ready to support it. And another user might have a whole different list that I haven't like seen something that solves it universally. There's a lot of proposals that just solve it for like that one user's group. And maybe my recollection of this KEP is inaccurate, but that's my experience with it at least.
I think we all agree about the problem, and that sounds like, and the solution could be different. Derek, I think about the proposal the proposed, the closed proposal. Actually, still it is per cluster base, per provider base still. So it still is kind of like based on the provider define a set of things, condition, and which is driven by the daemon side or whatever, and they have to give the signal, or it is ready or alive, and then it is like node claim it is ready. So based on that one, so you could be flexible based on node pool. Yeah, so I think the standard that could be, and it could be the per cluster, even could be flexible like the per node if you driving that one on the machine level. So, but I'm not sure the cap itself capture all those detail yet, because I forgot lost the detail. But I remember Vishnu did discuss with me behind the scene before propose to the signal. But from my top of my mind, if I remember correctly, didn't really saw some use cases because there's the class level of the admin, and there's some other people like what you just mentioned, like universal thing. They maybe have like the sub group of the node. They have certain of the admin requirement, how they are going to share those duty and override which one is which one. So there's some like the complexity, but I think that's at that time I do think about it is a little bit over complicated use cases. So we didn't provide a solution. So that's why I kind of like end up like since most vendor already work around the issue, so the end up we didn't really push that hard, that proposal much harder, because didn't solve the really extreme over complex cases. But I think about based my understanding today, Istio's use cases, I think that's enough to address that problem, but we should look into more detail. And so I just share my experience and my memory here.
If you had a pointer to the Istio specific concerns, I'd be curious on reading up on that.
Yeah.
I can link you to this on the race condition that we've had previously and the other mitigation efforts we have in place, if that's something you're interested in. Or I can write a new doc if you would prefer, that just specifically goes into what the requirements, or like what we would request from as far as kubelet or node support. Which would you prefer?
I guess either what's convenient to you. I guess the part I question is if you can get down to a single signal versus many signals. And the experience I was trying to raise was that, like, if you are a vendor working with SysDig might say the node is ready at a different point than the vendor that's working with vendor plus SysDig and says user workloads are only ready when the two are there. And so all that stands out to me is in the KEP that's linked is ideally provide a single signal. And I think that like that's a premise I still question versus having.
So I haven't added anything to the KEP, but my proposal would be more along the terms of this. What you do is we add a declarative API which basically states, it is a custom resource which defines inside of it a tuple, which is the name of the resource, the namespace that a daemon set or deployment would be in, the existence of a node selector, which you can use to define a node pool, which is optional, and you can just remove it if you want it to be cluster wide. And then a label selector for pod. And what it does is it specifies that a particular pod has to be ready, that exists inside of that namespace, so that it can be access controlled. You can't have people just randomly inject whatever workload. Exists on every node. Or exist on a given node before that node is considered ready. And so, for example, Istio would have one of these, and then you define another one for the use case of SysDig or whatever, or have another one for FluentD. And the node does not ever flip ready and start accepting schedulable pods until all of those conditions are met. because you can still have pods scheduled onto it that ignore the node readiness, via tolerations or whatever. But until all of those, until the node contains one pod meeting every one of those conditions, and all of those pods are in the ready state, it would just prevent the node from being considered schedulable. So it's similar to how the taint would work, but it's using just kind of the same, normal taint that you would have for most daemon sets already. That was my thought. So the signal is basically, does the pod exist and is it ready? And people that wanted to take advantage of this may have to convert whatever their workload is into something that just sits there and waits in a ready state. Optionally checking to make sure that the condition is still true. Does that make sense?
Yeah. Yeah.
I guess we don't need
to think through where that breaks down, and so either way, I think the problem makes sense if it meets every scenario. I'm not haven't given thought through enough, but I'll read the Istio one, Don, if you could open up access.
Yeah, I just link to back. I will. So Derek, we don't need to solve this problem for the first time. I think most, I just want to reintroduce that problem, because we do have this problem in the past, and we work around that problem, and also ask each vendor to solve that problem. But more and more, like the service is built on top of the Kubernetes, so they don't have like the vendor that like luxury to force the vendor, all those kind of things. So maybe we find the Kubernetes, how we are going to address this problem. This is kind of like the, maybe it's the time to reopen that issue, and we can discuss more. And well, it's not necessary that that is the implementation, is that the solution. But I just want to, we understand there's a real common issues for many users, like they provide a service on top of Kubernetes.
No, I completely empathize with that.
And also, I love you heard your story, like, because it sounds like definitely OpenShift or whatever you support customer have the same problem. I think this is
Swati's demo showed the SRIOV device plugin, right? So that has to be there before that node is considered ready. And thinking about the ready example here, the fleecing agent would have to be there. The struggle I have is like, should we just give up on the ready condition? Like, is it a bad premise to begin with? And should we promote instead other more specific conditions? And so it's kind of like, are we truly locked into what we originally had, or is there just another thing that we can think through? And that's what I haven't come to grips with in my head.
We can carry on that discussing, and I think that I can say that both have the pros cons. And when it is maybe like the surface complexity to the entire of the ecosystem, another one maybe is just cap off that that complexity to the node. But how we are going to be able to do that, and also because without those finer granularity, readiness or whatever condition is, and maybe it's not the best way. It's kind of like the one size fit all solution is not the best way to. So we can carry on those discussing. Yeah. We really run out of time, and the Sergey, I noticed that you asked the one question, and that question is pretty straightforward. You already put there, and people if against what you ask, and maybe then we can talk. And we can think about have like the room meeting. Otherwise, maybe we just go keep today's format. So then, because based on the policy, if the new meeting through the room, CNCF the room account, basically have to SIG chair and have to start those kind of meetings. So they basically have to either Derek or myself have to start that meeting. Then add unnecessary another like dependency on two of us. So if nobody strongly against and think about it is not accessible and it's not inconvenient, then we maybe keep that one for now. until someone have some inconvenience.
I'm pretty sure we can overcome this, so I'll follow up with Contribex to see what the options are there. But I feel like we can grow credential rates.
That's great. Okay, then I will follow up the SIG windows. Make sure they have like the proxy and the representative in at the SIG node, and Derek is going to follow up the SIG contributors and figure out a solution for those kind of things. Yeah, then we can carry on more discussing on the topology of while scheduling topic and also this node readiness signal more, and also the system reserve, because always kind of like the open issue. We need move forward and figure out if there's more generic or better solution enhancement for the Kubernetes SIG node perspective. Okay. Thank you, everyone. Yeah, nice to talk to everyone.
Bye.
Thanks. Bye.
Thank you, folks.